Okay, so this is topic 3.6, which is a really short lesson, is deviation from ideal gas law. So as the topic title says, it is some extensions or changes that made from ideal gas law. So there are two main causes of deviation, where the first one is the interparticle, or also known as intermolecular attractions. So if temperature decreases, the particles are much slower now, and there are more opportunity for intermolecular forces to work between them and to interrupt. So it's very obvious that if the particles are moving slower, they are having more time close to each other. That means the intermolecular attractions can happen more frequently. But there's no enough kinetic energy of particles that leads. Okay, Baran. So if there's no enough kinetic energy of particles, then it is not possible for the particles to overcome the strength of intermolecular force. So that's just the recap of what I have said before in scientific words. And the results will be the gas particles attract each other, leading to less or weaker collision with a container, and it leads to the observed pressure will be lower or smaller than the ideal gas law prediction. So if they're moving slower, not colliding fast enough, that means the actual pressure will be lower than the equation. And so the second one is the finite volume of gas particles. So ideal gas law assumes that gas particles have no volume at all. However, the real life gases, they do have volume. So if the pressure goes up, then they are much closer to each other, and the total area of the substance will be smaller, and that means the particle size significance is increasing. What it means is that when the total area is smaller, each particle size, even if they're same, even if they did not change, the fraction that they're taking up in the volume, the total volume is much higher. So the result will be that if space available for particle movement is lower than the prediction, then observed volume itself will also will increase compared to ideal gas law prediction. So to quickly summarize, the ideal gas conditions include high temperature, which has low attraction between each other, and low pressure, where the particle distance is high. However, the real gas conditions assumes that it is in lower temperature, which increases the strength of attraction, and in high pressure, where the particle distance decreases.